Hi everyone, I'm Jaco-Ben and welcome to the AnyLogic Modelers YouTube channel. I recently had the special privilege to interview a good friend of mine, Dr. Andrey Malykhanov, one of the big simulation experts, especially when it comes to creating digital twin simulation models of systems, and also the co-founder of Amalgama simulation company. We got to talk about a number of things, from how the advice that he's given me almost a decade ago when I first contacted him has changed and what he sees as the future of simulation modeling. We also got to talk about what are the characteristics of a good simulation modeler. Andrey also talked a bit about the exciting developments at their company, at the launch of their new simulation platform, which would be aimed more at intermediate to advanced Java developers, and they plan on releasing this later this year. We also got to talk about three of his role models that really helped shape his simulation career: Dr. Andrei Borshev, the CEO of the AnyLogic company, Dr. Alan Barnard, CEO of Cold Research Labs, and also Dr. Dennis Pregnant, who is one of the key developers of Arena and now the CEO of Simio. Thank you so much to Andrei for joining us on this interview.
So welcome everyone to the AnyLogic Modelers YouTube channel. Today we've got a very special guest and a very good friend of mine, Dr. Andrey Malykhanov, probably one of the great simulation experts in the industry currently and co-founder of Amalgama. Andrey, welcome. It's so nice to have you here. I've been looking forward to this interview for quite a while. We haven't seen each other physically for almost more than 2 years now. So tell us a bit about how you are doing. How's the company doing? What do you see for yourself in the new year?
Hi, Jaco-Ben, and hi, everyone. So yes, indeed, with all these COVID situations, so our ability to travel is very limited. So we are mostly now limited to domestic travel, and that's why we don't see each other. But we used to have perfect times when we were having a lot of projects for a lot of interesting clients worldwide. So the things are doing good. The things are going just fine. So there's a lot of business in spite of this COVID stuff, especially in the industry that we are focused on, that is mining, metallurgical industry, and many other like tough guys. With those tough guys, the business always goes well.
Yeah, they're tough. They survive these difficult times. And so with the company-wide, you mentioned previously that you guys are hiring, so I'm assuming Amalgama is growing?
Yeah, we are growing now. That's associated with our plan to release our own simulation platform. Hopefully this will happen this April. And now the sales of our MineTwin product have really started. So we've been advertising it for a year and a half now without significant amount of sales, and now it's starting. So that adds a lot of pressure on us to be able to not fail any projects.
Exciting stuff, and we'll be talking more about that a bit later in the interview. So in my previous interview I did with Philippe 2 or 3 months ago, I mentioned about you giving me advice back in, I think it was 2015, when I saw these great models on Run the Model. And for those in the AnyLogic community who's not aware of Run the Model, that was before AnyLogic Cloud. So you could upload your models to this website called runthemodel.com. And it was really, like, for me at least, it was groundbreaking stuff. You could upload the model to a website, you can send somebody the link, and they can play it online without having any of the software installed, etc. So it was really, really breakthrough stuff at the time. So in any case, I sent you a mail asking, what's the advice for me? I want to further my simulation career. I don't know if do you remember that email? Do you remember what I asked you? And so back then you gave me some advice, and in the short summary, it was something like, the most difficult part of a simulation model is how do you organize these stuff, the modeling stuff, in a sustainable and a logical system. And your advice was for me to go and look at big models I can find, whether it's winter sim conferences or examples in AnyLogic or even on Run the Model, and then to try and build those things. And you gave me such a lot of advice, and I think it really steered me in a great direction for my career. And there's some practical things like focusing on the reusability of your code, putting it in libraries, the design, architecture, a lot of focus on verification and validation. So to make a long question short, what would be your advice if somebody were to contact you today? Like, what has changed? What, based on the insights and experience that you've gained?
Well, so the more generic advice, I think, is gain your experience, build your own experience. But I guess that's not very useful and not very actionable, because it can be given to a specialist in any domain, right? So let's go down, let's land down to the earth and be more specific to the simulation. I think the first focus should be on the correct decomposition of your domain. So you should know what the key entities of your domain are. For example, if you do the mining, you should know what the agents should be, what the environment should look like, etc. With any other domain, you should kind of be experienced enough to see the boundaries, the borders between the entities. And you should decompose your domain in order to minimize the amount of interactions between the agents. So the agents or objects of your model should be as self-sufficient as it is possible. And here we come to the issue of reusability. And so it's always good, it's obviously good to make things reusable, so that you can spend less effort in the future when you need to model something very similar. But on top of that, the blocks of your model or anyone's model should be not only reusable, but separatable or separable from the general context of that particular model. And here we come to a very hot topic of unit testing of the simulation models. So if you build your model from bricks that are more or less independent and can be used on their own, then you can put those bricks and test them separately into your unit testing environment, whatever that is. And when you are sure that the bricks of your logic work correctly, then it will take significantly less time and effort to verify and validate your model.
Yeah, true.
Your model. So that would be the main advice. And what else? So probably the second advice would be to start the visualization of to find the proper way to visualize the structure of your model in its results. We'll talk later, I think, about Alan Barnard, but Alan taught, I think, both of us to debug the model just by looking at its visual representation, at its animation. So if a model is debuggable just by looking at its animation and statistics like plots and charts and graphs, etc., that significantly shortens the time of verification and validation. So the second advice will be try to build your model in a way that it is very clear to see, so it allows to clearly see what happens in your model just by looking at its visualization. So it's really, really useful, especially when we are validating it with your business client, with the business people, right? So that would be my second advice. So do you need a third one, or shall we stop here?
If you've got a third one, go for it. But I think what you mentioned now is absolutely crucial, right? Because the only way that your client or the business partners, whoever, is going to verify what you've done is through the visual part, right? The animation part. They can look at the results, and it just might happen that the number you are showing is close to what they expect. But whether the model was actually getting to that number correctly, they will have to look at the visualization, look at a chart, look at a plot, look at things moving on a map, right? Look at machines traveling around the warehouse and see, like, we'd never drive there. What's happening here? So just having that single number output is important. But like you said, having that UI is important for you as a modeler as well as for your client or the business partners. So you mentioned something about Dr. Alan Barnard. So I think, who else are like people that influenced your modeling careers or role models for you in terms of, what do you consider to be good contributions to your simulation?
Yeah, thank you. Very good question. So I think, as in probably any other domain of knowledge, we as simulation professionals are standing in this domain on the shoulders of giants, right? And of course, there are some giants that, published papers in Winter Sim conference proceedings in 1969 and 1965, etc. There's a lot of those giants of simulation that actually were the first guys who tried to use computers to simulate the reality. So they've made a huge contribution into what we are using now. But these are more like, this is more like a background for our professional life now. So for me personally, I think there are three people that are significantly important from the standpoint of my professional career as a simulationist. So firstly, I want to stress that I started to professionally work with actually working for the AnyLogic company. The AnyLogic is obviously one of the most, if not the most popular simulation tool nowadays. It's widely used, and your blog is entirely dedicated to AnyLogic, so that's good stuff. And when I started to work for the AnyLogic company, I think that was back in 2008. And of course, Dr. Andrey Malykhanov, who is the founder and the first developer of the AnyLogic company, was my role model back those days. So really, that is a unique person who actually found a way to combine the ease of building simulation models, so to combine the ideology behind things like ARENA and GPSS with modern style object-oriented programming. So back then in 2000s, that was a revolutionary idea, because there were no tools that allowed modelers to combine regular programming with those classical approaches to discrete event simulations and with those classical approaches to building mass service theory models with queues and delays, etc. And what I also want to stress is that AnyLogic, actually, there was I remember version 4 of the AnyLogic, version 4, and what was revolutionary about that version of the AnyLogic is it used Java, and Java it's today when Java is an industry standard in many applications and many software development applications. Back then, Java was just starting, right? So there were not even generics in the Java, so you couldn't create list of string or list of W. Any list was list of objects basically. So, but Dr. Malykhanov somehow foresaw that the Java will be very popular and made this decision to base this AnyLogic tool on Java language, which paid off and which keeps paying off now. So
what was what was AnyLogic based on before Java, before AnyLogic 4?
I think there was no publicly available AnyLogic before AnyLogic 4. Okay. So AnyLogic kind of started with version 4, and previous versions were just like more internal internal implementations, or probably they used it somewhere in their consulting project somewhere, etc. But it was not publicly well known and publicly available.
Okay.
Yeah. So one other thing that I can remember from and that I learned from Dr. Borshchev is that he always advised us to build the models incrementally, to throw in complexity, but step by step. To start with a very simple model. For example, if we needed to model a hospital, let's first model it as a source of patients, delay, which is the processing of patients while they are sick in there, for example, and the sink, or probably two outputs, right? For those who made it out, and for those who not. But let's first model it as a very simple system, and having already this system can give us a lot of knowledge about the object we're going to model, and then we can replace at any point of time this simple delay block with a more complex block consisting of internal structure of the hospital in this case, the resources, the patients, nurses, doctors, X-ray scanners, etc. So, but the top level structure will remain the same, but we keep adding on complexity. Then let's just replace all the constant numbers that we've hard-coded into this model with distribution. Again, the structure stays the same, but we are kind of adding new level of complexity to our model, etc. And he was not very happy when he asked me, for example, to build a new model, and there was no result after 2 or 3 days of my work, right? He always told, just build a simple model. Try to accumulate all the knowledge you already have about the system you're modeling in a simple model. And only then, once you've got it working, start throwing in the complexity.
Yeah, that's
so
that incredible advice. It's the same thing I've got in the blog post I had recently where we wanted to model this retail system. So you start, here's customers, here's a delay, here's they're leaving the system, right? And I think a lot of modelers don't start with that. Like they take the entire brief with all the steps, and like you said, now it takes them weeks maybe to get your first complete output. So it's always better to start with this like top-down approach. And when you go down in a specific area, you go like bottoms up in that area. So if you're going to model the hospital, you say, well, here's my one delay for, they're going into the hospital and then they're going out. You say, okay, now I'm going to break it up into maybe 3 delays, like they're arriving, they're being treated, they're being discharged. And then you take arrivals and you model that in detail. But the whole time, every time somebody asks you to run the model, you will actually be able to produce outputs, right? So if you focus just on the arrival center, you will never get outputs until you've completed all those steps. So that, I think it's really good advice, and I'd really recommend that to any modelers out there as well.
Well, so the other role model, the other person that greatly influenced the way I see things now professionally is the one who we both know, right? Is Dr. Alan Barnard. Dr. Alan Barnard is a theory of constraint professional. For those who don't know him, is a co-founder and owner of this Goldratt Research Labs company, who is providing services to clients, to big companies around the world. And he's a great specialist in this both strategic and technical implementation of theory of constraints by Dr. Jaco Goldratt. So Alan, I met him on one of the projects for PHP Bulletin, I think first, that was in Chicago, and we met back in 2013 probably, or 12. And what happened is, again, back then I was very kind of proud of myself that I am able to build such complex, so complex simulation models, and I was proud to be able to cope greatly with complexity, and I was really eager to tell all the people around how complex my models are, while he didn't like it from scratch. From the very beginning, he didn't like it. He just kept asking, just show me one plot so that I can see the state of the entire system.
Yeah.
Your system can be very complex, and all the systems are complex. And the models, your model can be complex, and you're probably doing a good job building complex models. But please communicate it to me clearly. Communicate to me what happens, what the hell is happening in your model, right? And let's just sit together and find a way to quickly build this representation, this visual representation. And Dr. Alan Barnard was the one who explained me this idea of cumulative plots. And it becomes especially powerful when you have several stages of your flow. It can be anything. It can be ore in your mine. It can be patients in your hospital. It can be cars in your city. It can be money in your bank, etc. Anyway, the flow goes through several stages, and you actually model the system that somehow handles the flow. Sometimes there are several types of flow in the system, but most of the time it's just the main type of the there is just one type of the flow of the material or entities that flow through your system. And if you plot this flow volumes cumulatively, step by step, for example, if you have a red line representing the cumulative amount of patients arrived to your hospital, then green line, let's make it more optimistic, representing cumulative amount of the patients left your hospital. Then immediately, by looking at this cumulative plot, you can tell whether your hospital is functioning good or not. What is the average length of stay for the patient in this hospital? Whether your hospital is coping well with the flow of incoming patients, etc. And probably you should make a separate blog post or a separate topic to do with these cumulative plots. I think many simulation specialists can benefit from it. So, and that is, and of course, there were thousands of other ideas that I borrowed from Alan Barnard, but this is, I think, the most precious and the most efficient one. So, and this is a very good tool for a business consultant as well. And as you probably know, when we're doing simulation projects for business clients, we are to a certain extent business consultants. So we kind of pretend that we are well-paid McKinsey guys to a certain extent. And I think we have to be like McKinsey guys and even better than them in some aspects. So this cumulative plot is a very, very efficient tool of visualizing what really happens in your system.
Yeah, we'll put some examples of this cumulative flow plot. I'm not sure if everybody knows what it is inside the blog post, and some links in the description as well. Anyone else that had a profound role on your simulation career?
Oh yeah, probably I would be Dennis Pagden. Dennis Pagden was one of the key developers of Arena, which is, I think, the most classical simulation tool out there now, even now. So there's a lot of people using Arena, and I think many of us started our simulation projects with Arena because it was back 10 to 15 years ago, it was the most popular one. So, but then after that, he left Arena for Simio. So he actually became a founder of the Simio Corporation, which these are the guys who do this Simio simulation tool, which is to a certain extent a competitor of AnyLogic. But what I liked about his ideas is in 2009, I was in Austin, Texas, in at the Winter Simulation Conference, and I listened to him then there, and he actually told that simulation is probably not that valuable without scheduling. So embedding scheduling algorithms inside of the simulation models, that is the future of the simulation. It was told back in 2009, and back then I didn't understand fully what he was talking about. And now I understand. And now it kind of hit us 2 or 3 years ago when we found ourselves that nearly half of our projects are now projects to do with scheduling. Some of our projects are even purely scheduling projects with no simulation involved.
Okay.
Some of them are mixed. But anyway, when you are trying to create a really serious simulation model, you will anyway have to simulate the way people make complex decisions about coordination between the system elements, between the cranes in the steel plant, for example, between the cranes and ladles in the steel plant, between patients and X-ray scanners and beds in the hospital, wherever people anyway do scheduling in real life, and you have to replicate that logic somehow.
Yeah.
So that is why scheduling becomes an essential part of simulation models, and this idea was actually revolutionary for purely simulation, the environment of pure simulation specialists back there in 2009. And now today we are even have this thing called simulation-based scheduling, where you do the schedule, you simulate the system working according to the schedule, but obviously you embed all the constraint interdependencies and variabilities into this simulation. And instead of yes or no, instead of getting a result of yes, the plan is feasible, or the schedule is feasible, or the schedule is not feasible, instead of that, you're getting a distribution that says, considering all the variability that you know, the probability of being on time with the schedule is 97%, whatever. So that is an idea that I think will actively evolve during the upcoming decades.
Yeah, I think that's crucial, right? Because if you look at a schedule, how do you know if it's a good schedule or not? How do you know if it's feasible on paper? You might plan it and everything fits in with the average time that it takes to move a ladle, the average time that it takes to heat up this, the average time you use an X-ray machine in the hospital. But in reality, there's variability, there's interdependency. So simulation is a powerful tool for that. So talking about the combination of simulation and some other technologies, what do you see the future of simulation and, for example, AI?
Well, I don't like the term AI in general. So AI is artificial intelligence. It can be applied to any algorithm more complex than 2 lines of code, for example, right? So AI can apply to decision trees, to machine learning, to optimization algorithms, etc. So it's more as a marketing concept now.
So let's rather use like machine learning, specifically, reinforcement learning.
Yeah, machine learning, I think, is a very, very hot topic today, and there is a reason for that. So there's a lot of tasks that are being successfully solved with this machine learning. And of course, we all know that a properly trained network can reliably tell difference between a cat and a dog on the picture. So that's kind of already with us. That's been with us for several years now. But what is more important is that in the world of simulation, we are very familiar with this concept of black box optimization. When you build a simulation model and you consider it as a black box, and then you need to find the best combination of its input parameters to that provides the best value for your output indicators, right? So that's a classical task in our domain. And I think that is where machine learning and deep learning and reinforcement learning can be used very actively, because instead of just doing a direct search or a algorithms such as simulated annealing or whatever, gradient descent, why don't feed it out to a neural network that would train and probably find the better solution in this, multi-dimensional search space. So I think that is where the best use of simulation model and machine learning will be. So in terms of other AI technologies, I think computer vision is something that can be also used for simulation purposes, because very often when we go and are asked to simulate some mine, for example, we lack the data. But nowadays, the cameras are everywhere. Why don't we collect the data using the computer vision? So, and here, this computer vision can help us to determine what is the average time between the trucks passing on the road, what is the average duration of an excavating cycle in the mine, etc. So I think that here that is not very obvious, but very promising use of AI that will help simulationists.
Yeah, an interesting application that we did in a recent supply chain model was to test some of the AI algorithms, right? Because now somebody's trained this algorithm and you want to see when it makes good decisions or not on your inventory management policy, right? And if you go and implement that in the real world, you don't want 6 months down the line to realize what the hell, the algorithm ordered, 6 times more than what we normally do, and now we've got so much inventory and it's a complete mess. So the simulation provides the safe space where you can test the algorithm that might have been created completely separate from the model, by someone else. But you don't want to go and implement that into your IT system immediately. You want to check it first, right? And you can do all that testing inside the simulation model to say, well, let's simulate your history, which is probably what it was trained on. That's good. Okay, let's simulate, complete variations of that for all the different parameters and demand patterns and the supply. Like, what if you've got a constraint in your supply and an increase in your demand? What will the algorithm do? And obviously, one of the benefits of simulation is that you can test that in a safe environment with fast feedback, etc. So talking about some of the other tools that's always available, I know you and I had a discussion about this previously. So what's the process that you guys go through in trying to find the right tool for the job, right? Whether it's going to be just scheduling, whether you're going to use Python, Google OR tools, AnyLogic, some machine learning or some other tool, or just data analysis inside R. Like, what's the process that you guys go through to decide which tool is the best?
Well, so that's an interesting question, and it's a very heavy loaded question, I think. So around about the tool, so we started this Amalgama company, which I am a co-founder of, obviously now 10 years ago. So it was on the 11th of April 2011, so it's now 10.5 years. And we started as a purely AnyLogic based company. So the only type of service we offered back then was development of AnyLogic models. And we sticked with AnyLogic for around, I think, 7 to 8 years. And finally, we found ourselves in the situation where we're just using AnyLogic's visualization capabilities and AnyLogic engine. For all the rest, we are using our own libraries. And that's very good that AnyLogic allowed to develop libraries with Java language and plug them in. And the fact that we developed our libraries, we actually capitalized all our knowledge and experience in that form of AnyLogic libraries. The fact that we had these libraries actually allowed us to build our AnyLogic simulations faster than probably anyone else in the world, or at least anyone else I knew. And 2 or 3 years ago, we experienced a lot of demand for systems which involved scheduling. And AnyLogic is not a scheduling tool, obviously, so it does not have any API for creating schedules, etc. And that was kind of a last drop before we decided to move on to our own platform. So because we actually did some simulation models with AnyLogic which involved scheduling, for example, that copper plant model for a company here in Russia, in Norilsk. But we just found that it consists of Java code for more than 95% of Java classes, right? 95% of the code of the model was in Java classes and was just the main object which kind of constructed the model from external Excel file and just started everything up, etc. And that was the point where we decided to internally try creating simulations on our own platform. So what we needed to do is to implement our own events engine, this discrete event engine. That was not very hard to do because there's a lot of classical literature about that, and simulation engine is not something people previously didn't do. So it required just reading some classical literature and accurately sitting and coding for a month, and then heavily testing what we've coded. And we also took this Eclipse environment, Eclipse framework, that allowed to very fast create desktop applications which were suitable for all 3 major platforms, which is Windows, Linux, and Mac OS. So we combined those things, and we've found that it is easy to transfer any of our previous AnyLogic-based model into this new platform, because we now have the simulation engine, and all the rest that we didn't use, all the rest of the functionality of AnyLogic we didn't use. And we actually, after the first project we've completed on this our new platform. So after the first project we've completed with this new platform, we've found that we're able to build our simulations and models even faster than previously. So, but that was a long way. And AnyLogic was a necessary stage in that way. So, and thanks to flexibility of AnyLogic, it didn't prevent us from looking at the things correctly, from designing our tools from the domain development perspective and domain-driven design perspective. So that was a great tool that allowed us to actually jump into this new era where we actually are using our own platform that is not anyhow limiting us. And of course, both with AnyLogic and now with our own platform, we actually use a lot of external libraries. And if you take Java environment, Java world, there's a lot of code, useful code that's already been written, like Apache libraries or Google OR tools libraries or Opta Planner library. All these tools have already been written for you. All of them have different license terms and terms, but if you study them correctly, you can apply them. Some of them are open source tools, some of them are closed source tools, but you shouldn't reinvent the wheel. You should reinvent the wheel, and you should make use of what's already available out there.
Yeah. So I think it's a really natural progression, especially for a company where most of the guys in the company are, hardcore Java developers, yourself included, and that really makes a lot of sense. And so, in talking about your own platform, I think that the first model that you built where the platform started was MineTwin, and I recently read, and we'll put the link to the article in the description here, about the success and the number of mines that's actively running your MineTwin simulation platform on, I would say, weekly, or is it quarterly basis, whatever, to do their actual planning. But can you tell us a bit more about that and how does it work?
Oh, yeah. MineTwin is the tool that is specifically designed to quickly create detailed simulation models of mines. And we now are capable of modeling both open pit and underground mines. And it also started with AnyLogic version. So we started to focus on mining industry probably 7 years ago. And back then we were using AnyLogic. But then after some time, we've realized that many of our mining clients, they don't just want to get the model, but what they do want is to get the simulation system where they would edit the scenarios in some type of user interface, including graphical editing of minefield, of adding and removing of passages, roads, etc. And this environment, they required that it was suitable for regular mining engineers. So what we end up doing is we created this Eclipse RCP application that describes simulation scenarios in the way familiar to mining engineers. And then it configures automatically the AnyLogic simulation. Back then it was AnyLogic. It configured automatically AnyLogic simulation model, and it launched that model. And after the simulation finished, it exported back the results somehow. And obviously the MineTwin was kind of a next step of this, where we got rid of AnyLogic part of the equation, and we kind of embedded simulation and scenario editing into the same application, we were able to make it more interactive, make the user interface more informative, etc. And finally, we've realized that what we've achieved for this MineTwin, we can actually apply in other different domains like manufacturing. And so we created this plant twin tool for simulating manufacturing businesses like assembly lines, aerospace and defense guys, etc. So we then figured out that we can actually split all the MineTwin architecture into the generic part, which is suitable not only for mining simulations, and this mining specific part. This mining specific level turned out to be very, thin. So it's just several dozens of objects probably that were tailored specifically to simulate mining, and all the rest became our Amalgama platform, which is a platform, a set of Java classes and libraries that allow developers to quickly build simulation systems, not just simulation models. And in the simulation system is a fully scaled application. It can be a desktop application. It can have some web interfaces as well. It can where the users can both edit the scenarios in the terms that are familiar for them and do all types of simulation experiments and scheduling experiments if it is required. So this Amalgama platform is we've been using it now for 2.5 years, I think, and finally we have decided to publish it in some form. So I think that will be firstly available to our partners worldwide only, but we are also considering open sourcing some parts of this platform as well. The parts like engines, simulation engines, the API for agent-based modeling, etc. Because the current APIs sometimes lack this orientation to commercial simulation models. For example, there's a perfect tool called NetLogo, for example, or many others. They are oriented to simulating in this approach of cellular automata, right? Which is not very suitable for commercial simulation models. So this publication of this Amalgama simulation platform will happen this April, hopefully. And yeah, so that will also partially solve the problem, which is the vendor lock problem. When you are providing some solution to a big business, this business wants to be sure that you are not the only vendor that is able to support that solution for many reasons, obvious reasons. So, and after we publish our platform, I hope that there will be a community growing around this platform. And as this platform is oriented at commercial simulations, most members of this community will be consulting companies and simulation companies providing professional services in the field of simulation. So there will be this vendor lock for whoever decides to provide services based on our platform.
Yeah, that's really, really exciting stuff. And I think just for those watching, so this platform is not going to be a drag and drop, and what you see is what you get editor. This would be like a plugin that you activate inside Eclipse, and then the entire simulation is created from pure code, right? There's no little drop downs and dragging things onto a screen. So it's a sort of a different market that what you guys are going to. You need to be at least some level, maybe medium level Java developer in order to use this. But I mean, I've seen this in your platform. It looks really cool. It's really powerful stuff. So really looking forward to that. I think any other things you want to highlight? We're reaching towards the end of our model. Maybe something about the future for simulation and AnyLogic or your platform. Where do you see everything going in 5 to 10 years' time? Are we still going to be building models, or are computers going to be building models for us?
Oh, well.
Will we still have a job?
That is provocative questions, right? So I think in 10 years' time from now, we will still be doing it ourselves, but the development of simulation models as development of any other software will be very much automated. And what will not be automated is conceptualizing, is designing the system, and designing the model that would really solve the problems of the business, the problems of the clients. So that part, I don't think it is possible to automate it, at least in the nearest 50 years, right? So these tasks will already be done by humans. And I think where all of this going is, we try to reduce all the inefficient and unnecessary work. So it would be great if we could explain somehow our idea on how we want to design the model and what should it do in the simplest way possible, but yet precisely on some formal language. And this description would be transformed into a model with all the user interfaces, fancy plots, animations, etc. I think that is the future of simulation, and that is the future of actually software development as well. Because right now, you probably know there's a lot of, for example, front-end frameworks in the browsers, right? So they all try to achieve this. They all try to achieve being able to allow the developers to simply formulate what they want and then transfer it to some code for the UI. So I think that is what will happen. Thank you very much for inviting me here. That was my pleasure to be able to have this interview. So I think that our industry is to a great extent underestimated. So everybody is talking about AI, computer vision, augmented reality, things like that.
The metaverse.
Metaverse, you're right. And our humble niche of simulation, I think, has a great potential for growth, especially now when there's a lot of tools and there's a lot of businesses that require the simulation. So if you are, an old-fashioned business without automation, you don't need simulation because it's too complex for you. But now we're getting to the point where most of the businesses, both big businesses and medium-sized businesses, have reached that level of automation and computification that actually allows them to collect data that is sufficient to build really useful simulation models. And I think that is what's going to happen in the years to come. But I think there is some fundamental reason why our industry is not booming, it's not exploding in volume, because simulation is a very complex industry. It's a very complex skill. So and I think that is kind of a natural barrier that prevents this industry from growing exponentially. And I think our task is to explain how can we do simulation models faster and more efficiently. And to do so, we must kind of share our experience in the form that is easily reproducible. For example, we should explain what abstractions have we found and are we applying in the existing projects so that other developers of simulation models don't have to start from scratch. So, but the danger in this is that the abstractions, the classes and libraries we create for simulating, for building simulation models faster, reflect our own experience and our own viewpoint, right? So they can be wrong, they can be suboptimal, right? But those abstractions, classes and libraries and ideas that survived several dozens of projects, I think are really worth capitalizing, publishing, and explaining to a wider audience.
Yeah, because they sort of stood the test of time. So, Andrey, thank you so much for talking to us today. I really appreciate it, sharing your time, your insights and experience that you've gained throughout the years. Thank you so much. Really appreciate it.
Thank you very much, Jaco-Ben. It was my pleasure talking to you.
Thanks again to Andrey. If you like this video, feel free to subscribe, hit the bell to get notifications of new videos, or go and visit the blog at the AnyLogicModeler.com. See you in the next video. Thank you.